All right, so now we're supposed to use Descartes' rule of signs to determine the maximum possible number of positive and negative real zeros. And then we're supposed to graph to verify the numbers with calculators. So we're not actually going to calculate them all, we're just going to verify it. Okay, so sign changes. Well, let's change to purple here. We're going to go from here to here's 1, here to here's 1, here to here's 1, here to here's 1. So that's going to be 4 or 2 or 0 positive reals. And then to get the negatives, we'll do f of negative x, and that's going to be equal to us 2x to the fourth. That becomes positive 10x cubed, and then plus 11x squared. Then it becomes plus, and then it'll be 15x, and then plus 12. So now, guess what? There's none. So there's going to be 0 negatives. Okay. So what we're going to do now is we're going to go, and I've already plotted the graph just so I don't have to take so long to type in the numbers. So I've typed that in, so it's already there. And so our graph, there's 1, there's 2, they're both on the positive side, and this is going to go up and do some other stuff up here, but it doesn't come back down. And so that says that we have 2 positive real zeros. And so that means our choice up here was actually going to be that one. Okay. And so it wasn't 4 and it wasn't 0, but it was 2. And there was also, we saw that there was nothing on the left side and the negatives. So there was none of those. So that all worked out really nice. So Descartes' rule does work. Now let's do this one, an application. So we're supposed to find the dimensions of a box. So what is the box? Well, it's going to be, length times width times height. So we're going to have some, I don't know, I probably can't draw it very well, but we'll have something that, looks like that. Okay. And it says the length is 3 times the height, and the height is 1 inch less than the width. Volume is 108. So again, the volume is going to be length times width times height. Now it says the length is 3 times the height. So let's say, because then it says the height is 1 inch less than the width. So because of that, it looks like everything's based on height. So let's let h equal height. And so length is going to be what? Well, it's 3 times the height. And the width, then, the height is 1 inch less than the width. So the width is going to be the height plus 1. Okay. So height is width minus 1, or we can say add that one over here. So width is h plus 1. So these are our values we're going to use here. I think we're going to use h, 3h, and h plus 1. Okay, so we're going to get volume in terms of h. So that means we're going to have v of h is equal to h times 3h times h plus 1. Okay. Now, what does that say? Well, we can multiply all that out. So that's going to be 3h squared times h. So that's going to give us 3h to the third. And 3h squared times 1 is going to be plus 3h squared. And we also know that's equal to 108. Okay, so now we know that. What can we do with this? Well, if we solve this for equal to 0, we get 3h to the third plus 3h squared, and then minus 108 equals 0. Okay. Now, what can we do here? Well, let's see. We need a factor. So what we're going to do is we're going to come back and we're going to do, some synthetic division, I think. But I'm going to see, this is 3, this is 3, 8 plus 1 is 9. So it looks like all of these are divisible by 3. So I'm going to multiply that whole thing by 1/3. So that becomes h to the third plus h squared minus 3 goes in there, 3, we have 1, 8, 3 goes in that, 6. So minus 36 equals 0. Okay. All right, so now we have to factor. So how are we going to do that? Well, we have to find our p's and our q's, of course, and go from there. Now, let's think about positive and negative zeros. So maybe we should write this up here. If we have, how do we want to write this? Where's our v of h? I guess we could write it as that is going to be equal to h cubed plus h squared minus 36. So there's one positive real possible, okay? And v of negative h is going to be negative h cubed plus h squared minus 36. So that's 1, 2, wait, 1. Oh, I see something I'm doing here. Haha, I'm not putting in all my values. We forgot the h value. Plus 0h and then minus 36. And I should have erased it down here too. Let's get rid of that 2. And then that's going to be plus 0h and then minus 36. And so we have a change here, and then it's plus, and then we could call that a plus again, and so we have that. And we could call this basically, I guess, a negative if we wanted to, and then that would be a negative as well. And so it'd be 1 and another one. So we could do that. So it's going to be one positive, and the negatives. I guess a key here thing is are we going to have negatives? Because if we think about this, this is going to be either 3, 1, and then if we call that a negative h, that's going to be 2 or 0 negatives. Okay. So how many negatives are we going to get here? Well, if we have a volume as positive, we have links that are all positives. How many negatives do you think we'll have? I'm thinking there's probably going to be 0 negatives, and there's going to be probably 1 positive. Okay, and then from there, we'll go from there and see. But now what we have to do is our P over Q's. So P over Q, and now we have 36. So 36. Well, what do we have with 36? Well, we have 1 and 36. We have 2, and we have 18, and then we can also do a 3 and 12, and we can guess what else we can do. We can do a 4 and a 9. And so this is going to be a 2 and a 9 and 3 and 3. We've got that factor there already. Oh, let's go ahead and do it anyway. And so it's going to be 2 and 9, 3 and 3. So we got 3s, 2s, 4s, 1s, 9s, 12s, 18s, 36s. So we've got a lot of numbers. And what is our initial value? It's a 1 again. So it's all going to be over 1. So we're going to have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus, and then we have, oh, there's going to be a 6 too, because 6 times 6 is 36. So, 6 and 6, we'll have 6. Now, we're not going to have a 7. We will have a 9, though. There's not going to be an 8 either. Well, yeah, there could be. No, there's not 8. Because 8 doesn't go in there. So it's going to be plus or minus 9. 10, no. 11, no. Plus or minus 12. And then plus or minus 18, it looks like. Plus or minus, it looks like then 36. Okay, so those are the ways we can break it apart. All right. So now we have to do all the division. So let's try to find our upper limit first, because we're only going to have positive numbers. We put plus or minus, but we know that it's going to be positives or negatives, but negative lengths and widths and heights don't make sense. So really we're only looking at positives. So let's do our positive 1 first. So we have 1, 1. Now we have to remember that 0 and negative 36. So that's 1, that's 1, that's 1, that's 1, that's 1. 1's not a value because that's not a 0 there. How about a 2? 1, 1, 0, negative 36. So we have 1, that's 2, that's 3, that's 6, that's 6, that's 12. That doesn't work either. All right, then we have 3. 1, 1, 0, negative 36. 1. That's 3. That's 4. That's 12. That's 12. That's 36. That's 0. Yay, we found one. All right. So, then we say, okay, well, then x is going to be a 3 is a 0. Well, we said there's only going to be one positive. So do we need to go any further? No, that's as far as we can go, because think about this also. Positive, 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 positive. So that's going to be basically our upper limit. Okay. And so we can't go any higher. And so that x is equal to 3 is going to be our value. But, we're actually having an h. So, that's equal to our h. We kind of switched letters because we're used to using these as x's, but it was actually an h. So that means height is 3. And we have what? Inches. And what is L? 3 times 3. So that's going to be 9 inches. And the width is equal to 3 plus 1, which is equal to 4 inches. Now, what does that give us? Well, 9 times 4 is 36. 36 times 3, well, we said that was going to be 108 because we divided by 3 and got 36. So that does make sense for our volume. And so those will be our real zeros here. Now we're going to have imaginary ones too, but we really don't worry about imaginary because we're not going to have an imaginary length or width or height. And so these are going to be what we need, because this one's going to give us h squared plus 4h plus 12. And those are going to give us imaginary numbers when we actually find those. So we are done when we have our real ones. Okay. What about the next one? Find the dimensions of a right circular cylinder. So a right circular cylinder looks something like that. And what do we know about a circular cylinder? Radius is 3 inches more than the height. So if this is height, then our radius is equal to height plus 3. Okay. So it looks like we're taking things in terms of our h. And so what is the volume of one of these things? Well, it's going to be basically our area of a circle times height. So it's going to be pi r squared times h. Now we just said r is h plus 3. And so what we're going to get is a volume in terms of, in this case, h is going to be equal to pi times h plus 3 squared times h. Now we have to square this. And so it's going to be h squared. Well, let's go ahead and do it. Pi h times h squared plus 6h plus 9. And if we multiply that out, that's going to be pi times h cubed plus, that's a 6h squared plus, and then we have 5 or 9h. Sorry, can't read my own writing. Okay. And so that's like that. And what does it say the volume is? Well, it says the volume is 16 pi cubic inches. Well, so let's set that equal to 16 pi. Okay. Well, guess what? That pi cancels that pi, and so we get 16 equals h cubed plus 6h squared plus 9h. And now we can take that 16 over here, and let's go ahead. I guess we could put it here, h cubed plus 6h squared plus 9h minus 16 equals 0. Okay, so that's going to be our polynomial we're going to work with. And we need to find the zeros. Okay, so if we look here, we're going to have 1 that's the same, and then we have 1 change here. Okay. And so kind of like what we had here, this one had 1 change. So we're going to have 1 positive possible real 0. And then that's going to be it, because if we subtract 2, that's going to be -1. That doesn't make sense. And do we really care about negatives? Not really, because we can't have a negative height, okay? But if we did it, that would be a negative, and then a positive, and then a negative, and then that's going to be a negative again. So there's going to be 1, 2. So it's going to be 2 or 0, negative zeros. And because we know it can't have a negative length or height, it's going to be 0 basically. All right, so now we need to do our P over Q. Now, since this time I know it's only going to be positive because we have to have a positive for our value, I'm going to only look at positives. I'm not going to look at the negatives. So we have a 16 for A, 0. So that's going to be 2 and 8. That's 2 and 4. That's 2 and 2. And we're also going to have a 1 in here because, 1 times 16 is going to have that. And then we'll have the 2 and 8 and 4 and 4. And okay, so I think we have everything. So we'll have 1 over 1, which is 1. We'll have a 2. We'll have a 4. We'll have an 8 and we'll have a 16. Okay, so that's all the different possible zeros. And now we just start dividing them out. Now, do we have all of them? 3, 2, 1, 0. So we can just start dividing. We have 1, and then we had a 6, we had a 9, negative 16. 1 times 1 is 1. That's going to be 7, 7, 14, 15, 16. That's 16. And that's 0. So our first one we tried, that is going to be the one that is the one positive real. And we called that one H. So H is equal to 1. So we know the H. And then the radius is equal to 1 plus 3, which is equal to 4. And we're in inches again. So this is inches. This is inches. And so we know our radius is equal to 1 inch. And our height, radius is equal to 4 inches. What am I saying? And the height is equal to 1 inch. Okay. Now, if we took and did r squared, 4 squared is 16 times 1, that's 16 times pi, 16 pi. That matches our volume here. And so that looks like it's probably a correct value. Okay. All right, so let's pause there and we'll come back for more.